Hello. Today is June 4th, 2024. This is SIG Node weekly meeting. Welcome, everybody. I want to start with a overview of caps that we have. We have in milestone, we already have 24 caps. So we're tracking almost a record number of caps this release. It's a lot of caps, and not all of them may get to the finish line, but I hope for the best. There are two of those caps that still don't have leads opt-in. Okay, so we fixed one of them, and another one, it's from SIG network as a responsive SIG is SIG Node. Okay, so we have. Let me share my screen. Okay, this cap deprecate status node info kube proxy version field. I feel that we discussed it some time ago, and this is just going to GA with it. So it should be fine. Okay, any objections to get lead opted in?
Sounds good. Yeah.
H stable. Okay. Oh, stage beta. My mistake. Okay. With that, we have 24 caps, all of them with the leads opted in. So it's a lot of caps. So if you...
I'm not seeing a lot of PRs actually. I mean, a lot of PRs open to reflect this reality. So folks, like, we're running out of time. If you want to get it in, you need to open the PRs to update the announcements.
Yeah, indeed. If you don't have a PR open and time is running out, you probably will be out of the milestone. But yeah, please try to do your best. Thank you.
Sergey, I think you can remove node swap from the list. I think we strive to GA at 132, so yeah.
This one?
Yes.
I actually don't know how to remove the milestone. 132?
Yeah, exactly.
Thank you. And I will remove it. Thank you. Okay, 23 then. Any other comments? Okay, if not, then we have a couple caps on the agenda today and a couple other questions. First is Chris. Are you on the call?
Yes, I'm here. Sure.
Do you want to share your screen?
I can share the... No, I can't.
Make you
disabled.
Yeah, I'll make a co-host really quick. Okay, go for it.
Okay, I'll basically share the agenda, and I want to just quickly talk about an issue that was, I don't know, discovered, brought up. We've kind of, let me start maybe here. We've found or identified some potential issues in the way that capabilities are used in a security context and even validated. So mainly, I have the documentation here. So if I look at the Kubernetes documentation on capabilities, that first of all tells me at the bottom that the cap prefix is not allowed for any of the capabilities in a security context. So instead of cap systime, I should say just a systime, no cap there. If I do that, that leads to basically different behavior for the different container runtimes. So for both cryo and containerd, it works. So the the container gets the relevant capabilities. But for container D, if I set the cap prefix, then it doesn't get the capability. For Griot, basically it doesn't matter. It will always get the expected one. And this is relevant in the fact that there's also validation for these capabilities inside the code. So depending on if I set it for cap, with the cap prefix or without the cap prefix, I then have validation. Let me find the summary here. For example, in the allow privilege escalation validation, I only validate with the cap prefix. So that means like I have the possibility of getting the sysadmin capability, even if the expectation is that it's not allowed. In other places, there's only the lowercase capabilities. Basically, they are never checked for these validations. So you can always set sysadmin in just lowercase, and that will give you a container with that capability. And validation will not fail. And yeah, same for port security standards, where it's basically just a list of this type of uppercase capabilities, and if any of them are there. So basically I am only validated this capability. I'm still allowed to basically use this capability without any issues. Sorry, the other way around. I have to add this capability in uppercase and can't add it in lowercase. Yeah. And the discussion, or the thing we wanted to discuss, was basically, is it kind of possible to align this behavior or to unify this behavior in a way that I'm potentially only limiting the allowed capabilities to a certain subset or a certain set of capabilities. So I can already fail on the user side as early as possible. So if I schedule a pod, then I know that if I set a capability, it has the expected capability, and that would mean on the developer, on the custom validation side, I'm able to kind of validate against this known list of capabilities and kind of only make validation or have full validation and ensure that the capabilities are set in a way that I expect them to be set, not have this kind of mix of different ways that capabilities are set. Any questions?
Chris, I align with you. I like your proposal, but maybe we need security folks, us folks, fill in the. I think when we initial added this validation, actually got there. So, but from high level, I do agree with you.
I mean, yeah, basically the initial feedback that I got from this proposal was we need a SIG to sponsor this as a potential cap, because it's a breaking change if we limit the validation further, or if we make it more strict. And SIG Node was just the first kind of suggestion there. If it's not the correct one or a different one is needed, I guess that's also an option.
This would be breaking API, right? Like pod API, if we make it tighter. So
yeah, I think you're going to have a hard time getting this past API review, honestly.
Yeah. And also even and also we need like the other cases right, for the anything on this kind of change might break about the kata lack of the container runtime behavior for sure. That's another complexity normally we don't capture at early design.
Yeah, I think what we can do internally is have a sanitization function that will convert it all to a single form. So at least the container runtimes get the same ones, and then we can clean things up on the runtime side.
Yeah, I would also say, like, I think an option that we have is we could like expand the possible values, and because you said it was container D that has stricter sort of requirements. So like, is there any risk in just expanding, containerd to be able to handle all of the variety of capitalization and prefix that currently does? That like Crowd does? Or that we like allow in the API?
I think that's where we can do this conversion on the kubelet side before it's sent to the runtime. So runtimes always get maybe all cap with cap included or whatever we agree on. And on the API side, it will be hard to change it.
Tim?
From a security policy perspective, I actually think that either doing the automated conversion or expanding containerd's accepted range would actually make the situation worse, because now the security policy really needs to make sure to, like, if you want to say you're not allowed to use cap sysadmin, well, now I need to check with and without the cap prefix, uppercase and lowercase. Whereas if I'm using a runtime that only accepts sysadmin, all caps or something like that, then that's the only case that I need to check. I agree that like if we were doing the API over, just making it essentially an enum, saying here's the like 20 or so values that you're allowed to put here, would be ideal. But also, as has already been stated, I think it would be hard to make that change with the current API for backwards compatibility.
Sam?
I put my hand down because I think Tim covered most of what I was going to say, but
Okay.
if we wanted to fix this on the containerd side in terms of expanding containerd to accept those, it would be fairly easy to do.
I mean, what currently happens is basically that Crow is smart about adding this cap prefix. So it only adds it if it's, so here it adds the cap prefix because it's not part of the initial one. And here it doesn't. But what happens on the containerd side is that if I set this capability, then I get cap sysadmin, which is not a valid Linux capability. So it's also possible to fix that on the container runtime level, but I'm assuming there are also potentially other runtimes that may have different behavior altogether. So it would be, in my opinion, best to fix this or to resolve this as early as possible. But yeah, it's kind of a breaking change.
Well, an additional option, if we do expand accepted values in containerd, we could also expand the cry test test to test whether or not we have the cap and the different, we could expand the validation for the CRI itself so that new implementations or other implementations can prove their conformance.
So what would be the behavior when we try to apply cap sysadmin? Will it be failure visible to customers, so just capability wouldn't be applied?
Currently, capability wouldn't be applied.
Okay, so I think it's a very good assumption that people who tried it and it didn't work, they likely don't keep this around, right? Because they probably found a way to work around it and specify it correctly. Okay, you're smiling. I understand.
So Sergey, then you don't consider this an issue, because why we ended up having this discussion here in this group is because actually we were looking to make the bind mount propagation which is required for CSI drivers today. We wanted to make this under the hood of sysadmin privilege, and we wanted to deliver that. And because we wanted to approach that, we ended up having the discussion for making the validation of sysadmin, for example, more stricter. That's why we ended up even here. And now it's a bit confusing, because you say it's good as is and we can't change it because of breaking changes in the API, which we of course don't want to introduce.
I mean,
but we are also keen to contribute that in terms for CSI.
basically, if you want to introduce a new validation that kind of either restricts a certain capability or ensures or makes it required that a certain capability is there, it's not really clear to how to do that on a code level. There's different ways it's currently done, and I think those may potentially need to be aligned, or there needs to be some way to how this should be done in the future.
And as a note to Tim's point about the app or the PSA validation piece, it looks like the pod security mission baseline policy does fail, does deny any sort of prefix of the cap plus any lowercase. So the validation that Containerd is currently doing is closer to what the baseline policy is validating against, but that validation doesn't happen on privileged. As far as we understand, they allow everything, and so in that case, any value that the runtime will accept would be accepted. So if we are to expand Containerd's supported set and keep cryo as doing what it's doing now, then we probably should also expand the validation in the baseline security profile.
I mean, so basically for pod security standards, this new and kind of improved validation already happens. So as Peter said, it happens on allows lowercase or doesn't allow lowercase. But for older existing validation, like this allow privilege escalation flag, that doesn't happen. It only checks against one specific string and only that one.
Right. Well, that's kind of that's the same as the current baseline validation. It's only checking against the capitalized without the cap prefix.
This one is checked.
And yeah.
So how do we wrap it up? What's the next steps?
Ideally, we would kind of align the validation to only allow this type of capabilities, but since that seems to not be an option, what are the next steps?
I think feedback from this group is we don't want to break pods. If somebody was able to specify something, they should be able to continue specify something, and expanding what is accepted by Containerd is preferable here. So I think some combination of warnings and expanding capabilities is a way to go. And ideally through the cap, so we can have broader visibility into how and what we change.
Mm-hmm.
Would you like to drive the cap?
Yeah, sure. I think I understand your goal, but I'll try to summarize it in the cap better than it. Then I guess we can discuss it further.
Thank you. Okay, with that, Peter, you up? Do you need sharing? Thank you, Chris.
Yeah, I don't actually think so. So I see Itamar here. I actually just put this on without talking to him, but it's about his PR about restricting access to high priority pods, and it seems like here, I can share the screen now that I have that. Or maybe actually I can't. We'll see if he allows it today. Do you see anything? No, it's whiteboard. Okay. So I'm struggling with this, so I'm just gonna not do that. So yeah, anyway, I'll send it in chat. But it's this PR. I'll put it in the notes as well. But it's basically the motivation is to prevent critical pods from having their service degraded because they are, you know, getting swapped, or more importantly, competing for disk IO while they're getting swapped. And so I wanted to just bring it to the wider audience here to see if people have, there were a couple of suggestions earlier today about a direction that we could possibly go in, but I just wanted to see if folks had any opinions on it or wanted to talk about it here.
I think another argument from the other side is, oh, I have a critical pod that I don't want to be killed if it can temporarily be swapped and survive. So that's the opposing view. So I wonder if it's more an opt-in versus something, some formula we come up from existing fields to determine, and then we push ourselves into a corner.
Yeah, I guess that basically my motivation here was that it keeps the current behavior for critical pods. So critical pods didn't have access to swap, before. So they won't have any swap access now. I get the argument that it's not configurable enough, and that's a fair argument. Now we barely have APIs for swap, and it's very implicit. But I think that's for the best, because to be honest, swap can be expanded in a lot of ways. APIs is just one of them. And I think that API expansion should be discussed in a follow-up gap. And we should look at this gap as fairly simple enablement of swap, which could be expanded further. Yeah, so I think, yeah, so I wouldn't go for adding more APIs as of now. Yeah, that's basically my view.
Okay. Any thoughts, folks? Go ahead, Eugene.
Yeah, I think I was the one leaving the comment there, asking about whether we need to surface this in another way. And I agree that we have all the, I think, use case. It's pretty reasonable for the critical paths to stay off swap. But yeah, I think it's just a general direction. Like after seeing so many different PRs that we done for swap, a lot of things are just hidden really implicitly and requires a lot of understanding, but lack of actual configurability from the user side. And that makes, at the same time, it's harder for people to actually either configure or actually to see and understand which pods are using it, which pods are not. I was just afraid that would create even more, I guess, issues down the road. But if this is going to be scope for another, I guess, separate cap discussion, then yeah, I'm okay with that.
Thank you.
Yeah, I feel the scope for the swap cap changed from what it was initially when we wanted to expose full API to just enable it, and we will try to do the best. And then like once we completed that, then we want to go into exploring other scenarios. I think, I think it's fine if we'll just repurpose the swap to that. And Antonio rightfully pointing out that original swap document is saying that critical pods is a good scenario for us. So maybe it warrants a bigger rewrite of cap README document.
Sure, if that's fine, I'll rework the cap, and yeah, I'll look specifically at this use case. Thank you.
Yeah, maybe you can put this as a future improvements that will be addressed in separate cap, because we do have people asking for just enable swap. I have like everything handled, like we need swap to use more memory for my like 1 or 2 ports on this node. So that is a scenario that we want to enable as soon as possible, and I think it's reasonable. And then once we have it, we have way more elaborate use cases, and people want very different things. So yeah, let's try to run to completion.
Yeah, sounds great to me. Thank you. Yeah, glad we all agree.
Okay, next is Dixie.
Yeah, I want to segue boost on this cap, which is about adding pod level resource spec. So I'm open to feedback from everyone here. I've already added a lot of people on the gap. So there are a couple of concerns that I want to discuss about. Number one is how to address the init containers with this feature. So there are two options that I have mentioned in the cap. One is to cap all the containers, including init containers, by the pod level limit. And the other one is to have phased limits, as in to have a different limit at the initialization phase, while a different limit afterwards. But the problem this poses is it will require significant changes in the QoS definitions. So in my opinion, I still feel that the first option in which we want to cap all the containers by the pod level resource limits is simpler. So this is one that I want to get feedback on. And then there is another comment on the cap by by Alexander. And he has mentioned that another unwritten contract between kubelet and runtimes is something that will create a lot of different problems for VM-based runtimes. So I want to understand more about that because of my very little understanding of VM-based runtimes as to what impact it could have.
Maybe we start with the first one. So
Yes.
I think for the first one, it's okay to go with the simpler approach, right? And we can always revisit it later on. I feel that the two-phase is too complicated. If we really have a need for, oh, my init container is going to use 10x resources and there are a bunch of times that happens, then we can add that. We can start with the simpler and revisit it later.
Actually, there's two different cases, right? So I think you need a container. Manu, correct me if I remember incorrectly. So you need container we already discussed actually because when we discussed about some how much we want to set for init container, right? So init container already take into consideration about those application container together, and because when we start this whole thing, init container also need a set limit. So we already, so that's why I think about we already covered that cases. For yes, and but there's the one things we definitely need to consider because set container, right? So especially for set container from the beginning, run as the init and until of the last of the app container end. So those kind of should be taken consideration when you use that. So that's the case by case. The init container already covered. So I agree with Manu. I mean, not to say like we simplify, it's like we already considered things from the beginning. Right? So that's what we want.
So I should add a section for sidecar containers, right?
Yes. Yeah. Because you have to differentiate the sidecar container from the init container. So that's two different things. Yeah. But init container, I think we don't have conflict there.
Yeah. Okay. Yeah, I think Sergey mentioned the same about the sidecar containers. So that's covered. Yuju, you have a hand.
Oh, Dan, I think init containers weren't actually completely covered in this. And because now we are setting the pod level C group using the user specified request and limit. So we won't have it's like either we follow the pod level request and limit set by the users, or we also consider the init container as a separate entity, like which may have higher usage during that time. So I think that's why Dixie mentioned this. But I agree with the simpler approach. Like I think simplicity is one main reason why user asks for this. And so if we can go with this one, and we can reevaluate if there are other use cases later that would require this kind of optimization, which complicates especially the QoS calculation within kubelet. So I think that's the current approach. Sergey?
Yes. You're so right. And here's the one subtle difference. What I'm talking about the pod level earlier, I'm talking about that's the default when user didn't set the pod resource limit. Then we go with our current approach. So once the user set, I think we have decided take that for as the one. And so yeah, once the user care about the pod level, so then we set the pod level and also container level based on what they decided, right? So could be container level, could be if user, I'm not sure this cap is already, we decided doing that one or not, but you and I discussed if customer don't set up the container, basically want to everybody just free to using pod level, then that container will set at the pod level equal to their pod level, like a parent C group. But if customer set, the user set pod level and also container, both container level, then the container level will always what customer choosing, user choosing. If it is no pod level, only like today, only container level. So then we set container level, and then that's basically is what we discussed. Like init container will be taken consideration based on the sum about the set container and the application container altogether. So that's kind of like what we kind of. This is still is the simplified version. I just want to say that this is kind of aligned with the this is the simplified version. We could evolve still, but that's kind of what we I think cover what we current cover, not to create off the backward incompatible use cases for customer, but at the same time expanded today by bringing the value for current use cases. I know there's more use cases for pod resource management. Okay.
I'm not sure I understand, but I don't know if we want to take time here. Like, are you saying we default the pod level limits to the sum of the container limits, even if it's set a pod limit?
Because today, most of the job, they don't set pod level. So this is compatibility. So
if you set a pod level where there wasn't one before, then things that
we already doing that. We were already doing that for init container.
I just don't know. Okay.
So if both are set, in that case, we want to prefer the pod level limits, right? Just want to confirm.
Plus, there's also have the pod overhead.
Yes.
I just keep adding, yeah, the pod overhead also is, yeah, always added.
So again.
Yeah, I don't quite follow discussion. I think when it's written down, it will be easier. I just want to warn everybody that whatever new scenarios for init containers we want to consider, we need to make sure that the assumption that Kubernetes takes that at any moment you can restart container and rerun init container for everything should be true. Like if node restarts, you should be able to start all the pods running with this node without like problems. So you should have enough resources for all the init containers of all the containers of all the pods on this node. So that assumption should be true unless we want to change something. And if we want to change this assumption, then it's a bigger discussion. And I don't think it will fit into this cap. This cap is already quite huge.
No, I think this makes a stronger case for this first option anyways, right? Like if we scale it down later, then we may not have the capacity to run everything at home. So,
yeah, but I mean, this assumption should be. I mean, if you want to challenge these assumptions, should be separate cap. Like today, we don't have a mechanism to unadmit pod or like wait on admission or wait for other init containers to run. So we'll just get out of memory and like I don't know what will happen. Like Kubernetes will not like it for sure. And the second thing I wanted to discuss is this gap is skimming over all this like topology managers, CPU managers, saying it's a problem for beta. I feel that we need to have at least some idea how to deal with those. Again, like init containers will be interesting challenge there. And overall, like when you have a pod level limits, how it deal with CPU allocation, that will be a very interesting conversation. And I don't want to like completely solve it now, but I don't want to go into alpha without even understanding how it will work with those managers. And those managers are almost GA, like almost all of them GA, so we need to account for them for sure. So those are two comments I want to give.
Yeah, I think, Sergey, that was a miss. So I have thought about at least topology manager in my head already, and I'll add it from my notes. And also for the other managers, I'll just have a high level overview in each section there.
And another thing is earlier we talked about mostly on the guarantee course, right? So first of all, we also need to discuss more. Right? First of all, best effort basically is just simple. You just using all those whatever Slack on the node. But first of all, we need to figure out what's the maximum, what's the cap, and because you need a guarantee of the guarantee have one, and so we need to talk about that.
Okay. And
Sasha
other
signing up
questions?
to deprecate topology managers, by the way, if you look at comments.
Well, you know my opinion. It doesn't reflect the current state of the hardware. So
Yuji?
I couldn't follow that.
Sorry, I asked about topology managers, and Sasha commented on the chat that those needs to be deprecated.
Okay.
I guess
it's a sidetrack. Don't pay attention to it. Sorry.
But I think that's a I guess reasonable point to discuss. What should be included in the beta scope, right? We can talk about a high level how this could be integrated in the CAB, but I also think even with a more restricted scope that doesn't support other resources, this has its use case and benefits to the users. And like we could also consider limit the GA scope and then come back to extend that to other things later, especially if we do expect more changes in, I don't know, topology manager and other things. That could be one approach. Just want to hear if anyone has any opinions on those kind of things. What kind of features need to be supported if this feature goes to beta and GA?
I think my position is every feature needs to be supported, which is GA. So like if swap is ahead of it, so swap needs to be supported, and swap has some calculations on how to account for swap for different containers. We need to provide new calculation for swap, for instance. Topology manager is similar way.
So are you suggesting that I should add a section for swap as well in the high level overview?
Eventually, yes, for sure. I mean, we already like swap logic wouldn't work very well with the new pod limits. We need to account for this and make sure that it works together.
Yeah, I think maybe at least we need to make sure that we are not in a position where we cannot retrofit those things. We can say, okay, this at a higher level, this is how it could work, even if we don't have the details nailed down.
Okay, sounds good.
But I want to warning people can swap. You cannot enable even from the API. But I just want to make sure when customer using the pod resource limit, it's not break like the swap usage, right? So but at least but the swap actually the requirement is different from other resource management. I have to say.
Okay.
Right. Because you cannot validate even at the API level. Because we don't allow those kind of things at the API level. When you say, oh, this is an invalidated request or whatever things, you cannot do anything. You also cannot schedule based on those kind of things. But the pod resource limit, it is at the API level, at the pod API level spec user can use it. So then can be validated, can be those. It's different from the swap. But I do think at the node level, we need to make sure this is compatible, coexist feature at the level.
Okay. I believe this is that.
Yeah, I think making sure compatibility is more important than, say, supporting all of them and integrate with all of them to work for all the features, even for the GA scope. I mean, that's my personal opinion. I feel like we are making a lot of changes, a lot of features at one time. And if we can make sure they're compatible, and in certain cases, they don't work together, which can be configured properly, then I think that's also a reasonable trade-off.
Okay, sounds good. And do we want to address the VM-based runtimes? I am not sure of what changes that would entail, but at least for the non-extended resources, I think it shouldn't be a problem, but open to hearing different ideas here.
Yeah, so as I wrote this comment, I will probably expand about what I mean by that. So practically, with introduction of pod level resources, we are creating well, not creating, but extending the situation of having two chefs in one kitchen. So we have kubelet who is modifying some cgroups parameters, and we have a runtime. And we are creating additional contract between those two components, like what, based on the assumptions of what is going to happen. So for normal containers, it might work, but for VM containers, it will create problems. If not right now, it will be in near future. A real simple example. So let's imagine you have on the pod level, you're setting request 4 GB of memory, and you have two containers which at the moment requesting only, let's say, like 3 GB of memory initially. So what happened is VM-based runtime, it doesn't know anything about the pod signal. It doesn't know anything about the parameters applied there. What it gets from CRI protocol saying like, you are going to run two containers, total amount of requested size is 3 GB. It will create the 3 GB VM for it. So what we end up is what kubelet thinks what we allocated 4 GB. VM created 3 GB and 1 GB is not used. So like we have a wasted resource. Same applies to limits. So like when on VM creation, we can assume what, like based on the information what we got from containers, what to do. We don't know what kubelet will put on what parent group. So what I would like, my main reason of my comment, I would like to see in this cap, what if we're introducing the pod spec for fields on the pod level for request and limits, we are passing that information down to CRI, what runtimes can react on it.
Alexander, I thought you may, or I thought this pod level resource limit may help VM container use cases, but maybe I didn't got what you said. Because initially in the past, we don't have this specified, right? So, but to make this VM container work, so we even introduce, of course, it's not just for the VM container, but it is that most of the use cases. So we introduce this pod overhead even because.
Yes.
Right. So now we introduce this pod resource limit. There's the two things you can use it, right? So one it is what we today we have, which I think is painful for you because you need to mess up or try to do this kind of the pod overhead. I remember there's the one chance if you have the VM container coexist non-VM container on a single host, the pod overhead actually a little bit difficult for you to use in this runtime class. If I remember correctly, there's the 2 years or 3 years, one signal that you, maybe it's you or some other one from the Kata container mentioned this one. So then we introduce this, because you have the different overhead on a single host. So it's difficult for you to specify which one to use in. If I remember correctly, because so then we have for this pod resource limit, basically it is you can upfront, right? When you schedule, you could even using when you have cluster and you decide using VM container or whatever things, you could upfront to before the admission part, you could, okay, this is bad practice, but
Hey,
I want to
Don,
say,
hey, Don, can we have 3 more
you
topics
inject
on
stuff in.
agenda? Can
Don,
we move the
Don,
discussion into comments?
quickly, can I respond? So the pod overhead is for taking into account the additional kernel and additional system of a VM, and it's fine. And the main thing is the pod overhead is communicated from the kubelet to the runtime. For this cap, what Dixit is proposing, there is no communication between kubelet and runtime. That's the thing what is missing, in my opinion.
The pod level limits are not communicated. Like they are being set but not communicated to the runtime. I mean, it might be wrong, but it's the same today, correct? So my question is, even today the kubelet sets the pod level limits, and that's not communicated to the runtime. So it's still the same thing then, right?
It might lead to different decision on the VM creation time about how much of resources will be available for this pod.
Okay. Yeah, let's chat this outside of this meeting then. Yeah, and let other people.
Yeah, this intersects with the KEP like Zvonko and was presenting a couple of weeks ago, right, Sasha? Yeah, let's continue on chat.
Yes, what Zvonko and Marcus are, it might help, but it's not completely directly related. But it's the same area.
Yeah.
I think the ask is just to that CRI or the runtime aware of the pod level resource limit and request set by the user, right? That's the main ask for this information to be passed down to the runtime.
Yes, explicit contract and instead of implicit.
And that's discuss what we use today, currently today, and how this could be better, in the chat and comments.
Okay, I hope this exhausts this conversation, and we have more topics on this cap. Please know that deadline for 131 is coming up. So if we hope to get it in, let's expedite those conversations. Next, Philip.
Okay, so I would like to give an update on the node maintenance cap. So to refresh people's memory, node maintenance is basically better kubectl drain, and evacuation is basically better eviction API. So we have decided to move the evacuation API from the node maintenance cap. So it's a standalone cap now. And we have also other dependencies on the evacuation API. So, and we are targeting the evacuation for 131. I still need to update the issue labels, but this is 131 and the node maintenance is 132, I hope. And some notable changes we have done in the node maintenance is that we have included a drain plan. So the expected behavior of the node maintenance is that we would like to give an intent to actually be able to remove any pod from the node. So this means also the daemon set pods and also the static pods. So this would also need an integration with kubelet. And one of the features is also that we would like to augment the graceful node shutdown feature. So yeah, and also last time we had questions about like the permissions for the node maintenance. So we would like to condition first the evacuation should be conditioned on the pod deletion permissions, and the creation of the node maintenance should be conditioned on the node deletion permissions. So yeah, that's basically all the changes.
I think, Philip, we may benefit if you can do a small walkthrough. If I remember correctly, you had an interaction, like sequence diagram or something that may be useful to share here. Not sure if you have the time to cover it today or if you want to grab a slot next week.
Yeah, we can go through that. So like the sequence diagram, it was moved to the evacuation API mainly, which does most of the logic of moving the pod out of the node. So like the node maintenance API is mostly high level. Yeah, so yeah, but I can go through with that, and we want to we are looking for people to review mainly the evacuation API these days, so we can move this to 131. Yeah, thank you.
I want to know that there is a email thread on SIG architecture concerning about introducing more APIs that are very infrastructure related. So this one listed there. Maybe interesting conversation with SIG architecture as well.
Yeah, I'm planning also to bring more awareness and to ask for feedback on Kubernetes dev mailing list. Yeah.
Yeah, I remember another feedback we had beyond security is how all the scenarios will be covered. Like, is it like excessive list of scenarios that will be covered by this API and like everybody will switch to it, or it will be yet another API that will have yet another logic implemented. So we'll have like, instead of 4 ways to delete a pod today, we'll have like 5 ways to delete a pod. So that was another feedback, and I don't know whether it was addressed. I haven't read the cap yet.
So yeah, basically it will be another way. So we have looked into changing mainly the eviction API and the pod disruption budgets, but this is very hard to achieve without breaking the backwards compatibility. So it's basically a new way to do things. But when we get the more adoption of this API, for example, the cluster autoscaler or the kubelet and the controllers, then it will become beneficial to the users.
Okay, we only have 2 minutes. If there are any more feedback on this, immediate feedback, please speak up.
Yeah, immediate feedback, I'm just not sure. Do we have enough time before the flows? Right? So this topic is really important topic. We need to move forward, but I'm not sure we can meet 1.31 frozen time.
So both of these caps are marked as SIG apps. Do you want to also include SIG Node there? Because otherwise we're out of visibility here.
Yeah, I think for the evacuation API, I think it's optional for SIG Node, but yeah, that's the one that's in a hurry. So if you like, you can take a look at that. But yeah, the node maintenance is more important for SIG Node.
So node declarative, we do have some of the volunteer to review. We don't need to wait for 1.32, right? So people can review. Then actually volunteer to review this one. Yeah.
I'll take a look.
Yeah, reviews are welcome. Thanks.
Okay. So yeah, so the ask here is to get somebody to review. And I want to, like, even if the evacuation API will be approved without SIG Node approval, it wouldn't mean that SIG Node will implement the changes. I just want to be clear that like SIG Node needs to review this. If you want kubelet changes, it needs to be reviewed.
Yeah, it would be better if you review it. Yeah, that's for sure.
Okay, very last topic, we're out of time. On SIG Node chat, Slack chat, there is a request from release team that some tests started flaking. In the past, we didn't see those flakes or like that many flakes. Now, the release team is a little bit like sending warning messages because they want to have clear release blocking dashboards. So we will discuss it on tomorrow's CI meeting, but even before that, if anybody has time, please take a look. I know Anish is helping with that. I don't know if Anish is on the call. Yeah, thank you, Anish. If you can continue doing it, that would be great. Okay, with that, thank you, everybody. Bye-bye.
Thanks.